So now again, as I was saying at the beginning, this event is sponsored by the two graduate programs. So we are going to have one talk by a student now and one talk by a student at the end of the evening session. So, and the chair is also going to be a student. So, Victor.
Okay. The next talk will be given by Andrés. Andrés Quijano studied physics and advanced technology at the state of Hidalgo. He did some research programs at Emmanuel, National Institute of Astrophysics, Optics, and Electronics, and an Institute of Radio Astronomy and Astrophysics. He's finishing his master's in social science here, and he will start a PhD here in philosophy science. His talk is about ignorance, structure, and structural science.
You cannot start talking.
Hello, everyone. I'm very glad to have all of you here. And, well, I will begin now. Maybe not now.
Once and then.
Pero aquí creo que okay. So, my central question is this. Are the prediction criteria the central epistemic criteria in historical sciences? That is, do we evaluate theoretical structures in terms of its capabilities of making predictions, or are there other epistemic criteria to evaluate these structures? I understand for historical sciences, cosmology, paleontology, and geology, etc. My claim will be no. There is significant structural ignorance regarding relict novel objects that impedes that we have legitimate predictions. Although theoretical structures in historical sciences can actually make predictions, very often we do not meet all the criteria to have a successful prediction. For this, I will take the cosmic microwave background of radiation that is very often claimed to be a prediction of the Big Bang theory of cosmology. I will show that, in fact, although it was a prediction, a theoretical prediction, we do not, cosmologists did not meet all the criteria to have a successful prediction. All right, so let us begin. First, I take for a theoretical structure a plurality of relationships that hold between claims or inferences, something very general. We can have a theory, model, narrative. I do not want to keep I do not want you to concentrate here. It is just an umbrella concept. But this is going to be central. So what is an anticipatory prediction? A prediction for short is a novel empirical consequence of a certain theoretical structure. So we have Bose-Einstein condensate. That is a clear example of an anticipatory prediction that was corroborated after. The term novel is very important because we have many interpretations of what can be novel, a novel prediction. First, we have temporal novelty. That is, the phenomenon was predicted before it was found. So that was the case with Mercury's perihelion, no? But gravitational lenses, for example, Bose-Einstein condensate, and etc. But also we have use novelty. And that is that the phenomenon is not like built into the theoretical structure. But also that no other theoretical structure can predict the phenomenon. I will throw this to the trash and just take this. So the phenomenon needs not to be built into the theory in order for the theory to predict it. Are we clear here? Yes. Perfect. So now, what is the prediction criterion? This is something that you might think in terms of Popper's philosophy or Lakatos' philosophy. And the prediction says that a theoretical structure is non-negatively valued if it is capable of producing certain anticipatory predictions without recurring to post hoc or adjustments or ad hoc or etc. And experimental research actually finds this phenomena with a reasonable error interval. Now, when a philosophical stance takes the prediction criterion as central, this if changes to if and only if. Yes? I will say that the prediction anti-criterion is simply the negation of the prediction criterion. In this sense, a theoretical structure is negatively valued if it is not predicting anything, or experimental research do not find the phenomena predicted. Again, as if a philosophical stance take this as central, it will be an if and only if. This is important because in historical sciences, we have had reflections about how suitable are these criteria. For example, Carol Cleland rejects the prediction criteria for historical sciences with this argument and says that in experimental sciences, we have underdetermination of causes. That is, a single cause does not determine univocally a single phenomenon. So, prediction is a good criterion because it serves to cut the possibility space. However, in historical sciences, we have overdetermination of causes. Why? Because a single historical event can leave many traces. From very few of these traces, one can infer one and a single event. So, prediction is not a suitable criterion for historical sciences, but the capability of grabbing a lot of phenomena. If a single cause can explain varied and many data, it will be good value. This is important because it has been claimed that cosmology is a historical science, but there has been no rigorous argument about this. I will also not give that, but I will claim that if we think of it as if it were, then we can have good results. Now, in cosmology, there is a debate between theories. First, we have lambda CDM, that is a standard theory of cosmology, the standard model of cosmology, and we have MOND. And these are two strategies that of which the aim is to explain cosmological data. Philosophers have claimed that we can take Popper's insight of philosophy and create a new scheme that values positively MOND, that is not the standard, and values negatively lambda CDM. I will claim that that scheme is biased. Why? Because if we take the Neo-Popperian scheme seriously, then it should also explain why we chose Big Bang theories instead of steady-state cosmology. I will claim that that is not possible, so it is a counterexample. So the argumentative strategy is going to, I'm going to reconstruct first the Neo-Popperian scheme. Then I will explore, reconstruct and apply the Neo-Popperian scheme. Then I'm going to explore what do I mean for archetypal research situations. My argument to reject predictions are going to depend on this So that will be important. Then I will introduce the argument from ignorance, that is the rejection, and suggest alternative criteria. I will not construct a different theory choice scheme. However, I did my master's thesis on that. So if you're interested, you can come to me. And we can. Okay, so let us begin. I just want to show you what people have said. So, as I have told you, lambda CDM is the standard model of cosmology. However, the strategy is to keep GTR, I mean general theory of relativity, and introduce some dark objects, dark matter, dark energy. We do not know what is dark matter or dark energy. So we cannot make, it is not that we cannot, but it is very difficult to make predictions. Mond is an alternative that makes predictions. So taking Popper's insights on philosophy, these philosophers say, well, Mond is better. You should throw all cosmology to the trash and make it all over again, but with Mond. I reconstruct the Neo-Popperian scheme like this. If T1 has clearer falsification criteria than T2, and T1 is the only alternative to satisfy the prediction criterion regarding some phenomenon, and T2 does not, then it is rational to choose T1 and irrational to choose T2. It is rational to choose T1 because it aligns with the critical falsificationist attitude. That is, it has clear falsification criteria, and it is the only alternative to predict certain phenomena. It is rational to reject T2 because it is aligned with the uncritical verificationist attitude. That is, that we only want to graph positive empirical data, and all other things are rejected. Now again, if this Neo-Popperian scheme is right, it should explain why Big Bang, why we chose Big Bang instead of steady-state cosmology. So let me introduce you very fast to Big Bang and steady state. First, Big Bang is based in GTR, expanding cosmologies, that is Friedman standard cosmology. And it looked for a super dense and super hot stage in which heavy elements could be formed. That is the Big Bang. There were two versions of Big Bang. First, we have cold Big Bang, in which we have matter dominance. But we also have hot Big Bang, in which radiation was dominant. I mean, what is the primordial thing that matters? Cold Big Bang says matter, hot Big Bang says radiation. This is important because in the context of hot Big Bang, Alford and Herman predicted a relict isotropic signal of radiation that is about 5 Kelvin. And that is the prediction that the Big Bang theory is made. However, there were some problems like the mass gap problem and the age paradox. So for theories that had zero constant of cosmology, we had that the universe was younger than the Earth. That is the age paradox. But also, although the aim was to explain how heavy elements were formed, no heavy elements could be formed. We could only form light elements, that is hydrogen, helium, and some other traces. But I think that the atomic number had to be 5 and 8. Above that, no elements could be formed with the mechanisms that it had. Moreover, there was no Big Bang theory, but Big Bang theories. There were many of them, and people complained about that. In fact, specifically, the people in steady state band. So they said this, it has many parameters, there are no clear falsification criteria, so you should choose my, my theory. And in that theory, we had the perfect cosmological principle that simply says that any observer at any time, at any point, would observe more or less the same. It has no mass gap and no age paradox problems, but also it made clear predictions and have clearer falsification criteria. So here they also claim that the steady state had to be chosen instead of Big Bang. In 1965, it is very common that you read that it was discovered, the CMBR was discovered. For example, you can find that in Dürer. What they found was a rare signal, but as I will explain later, that was not that it was not the CMBR, but they had no elements to say that it was the CMBR. And that is going to be the key argument for this. So let us evaluate this rivalry between theories with a Neo-Popperian scheme. If cosmologists chose Big Bang, then it had to be the case that Big Bang theories had to have clearer falsification criteria than steady state. But also, it had to be the case that Big Bang had to be the only alternative to predict, for example, CMBR, and steady state theory had not to. As I have explained, the first condition is false. Big Bang theories were not more susceptible to be falsified than steady state theories because it had many free parameters. And in fact, steady state theory was more keen to be falsified for this effect that says that for younger galaxies, you observe more red light because we have more red giants. That is the word. The second condition is false because although Big Bang theories could predict the CMBR, they were not the only class of theories that could predict it. We had also cyclic theories. In fact, the people that interpreted the signal of Penzias and Wilson were working in this kind of theories. In this kind of cosmological theories, the universe expands, it reaches certain limit, and then starts to contract. In this series, we also have a prediction of a CMBR that is something between 20 Kelvin and something like that. So what is the conclusion of this? The Neo-Popperian scheme cannot explain how we chose Big Bang instead of steady state. In fact, it cannot explain how we adopted or rejected any of them. Big Bang's adoption was not rational because it had no clear falsification criteria. However, Big Bang rejection was also not rational because it made a prediction. Steady state rejection was not rational because it was aligned with the falsificationist attitude, that is, it had clearer falsification criteria, but its adoption was also not rational because it satisfied the prediction anti-criterion. That is, when the signal was found, steady state cosmologists said, well, yes, you have a signal, a background signal, but it could also be caused by the sum of all galactic starlight. So, what is the conclusion here? Although it is not satisfying the Neo-Popperian criterion, it is satisfying the prediction criteria. Big Bang made a prediction, steady state fitted the data. What can we say about that? Well, let me introduce now some concepts, some differences between experimental sciences and historical sciences. So a clear difference is that in experimental sciences, the results are repeatable and manipulable. So for example, we have a coil and we can modify the number of turns that the cable is doing and the current that one introduces to the cable. One can predict how is going to be affected the intensity of the magnetic field. We can manipulate that and repeat the experiment. However, historical events are not manipulable. Moreover, they are not repeatable. They are often unique. So there is no sense in which a cosmologist can go back to the beginning of the universe and vary some parameters and see, well, what is the universe that we have now? There's sadly no way to do that. Moreover, the access in experimental sciences depends on procedural knowledge and material conditions. For example, for the Bose-Einstein condensate, the things that were key to discover this was to develop a good technique to cool down the gases to the temperatures that were needed. However, historical events depend on historical reconstructions. Again, there is no sense in which we can manipulate historical events, but it is more than that. Let me stress this point. In historical sciences, we depend on relic objects. That is, the objects that remain from certain historical event. It is possible that certain relic objects are destroyed. It is in historical sciences we have less epistemic, less empirical support because there are traces that might be lost. That is what I wanted to say. Why? Because relic objects are kept in environments that do not enhance information recovery. That is also a key difference between experimental sciences and historical sciences. So in experimental sciences, the environmental conditions can be manipulated so that scientists can enhance information recovery. For example, the Higgs boson was discovered because scientists were able to produce a higher rate of collisions and also a higher energy in those collisions. But in cosmology, for example, we cannot observe directly the CMBR. Why? Because we have another clear direct field view. For example, in this image, you can see our galaxy preventing us from observing perfectly the CMBR. Also, the recovery of information is limited to the quality of the relic objects that we have. So it could be the case that some relic object was preserved, but some properties of it were destroyed. And that limits or the empirical support that some theoretical structure can have. In distinction, in experimental sciences, the information is limited partially to the sensitivity of measurement instruments. For example, certain scientists are always adding things to the collider so that they can recover more information. Now, let us begin with ignorance. And who is the best philosopher for ignorance? Of course, Maria. Now, what is factual ignorance? I will take it just to mean that a certain epistemic agent doesn't know what is the truth value of certain proposition. Yes. So, for example, I don't know if I closed my door. I don't know the true value of that. Yes, but objectual ignorance is absence of knowledge of a certain particular object. Its primary consequence is that you cannot assign a certain list of properties with a certain object. For example, I might know that in this institute there are some squirrels, but I do not know what are the correct characteristic of those squirrels. Also, we have ignorance of theoretical structure, thanks to, again, Maria, and that is the absence of knowledge of privileged inference patterns that preserve the empirical success of a theory. There is a very important point here, that is that if we don't know a theoretical structure, if we ignore it, it can be due to two causes. It may be that we do not know what is the form of the structure, but also that we do not know if it is the correct theoretical structure. Note that it says that that we don't know the inference patterns that preserve the empirical success. Yes, so that is going to be very important. When historians discover novel relic objects, first they ignore this that I'm going to call the proposition I. They ignore if a certain relic object was in fact the object that was related with a historical event. So, for example, when geologists found a crater in Chicxulub here in Mexico, they didn't know if it was the crater of the asteroid that extinguished dinosaurs. But also, why do they ignore I? Because they ignore the temporal trajectory from the object that was related with the historical event. Let me just say omega, and omega tilde for the thing that we have in present. Omega is the thing that is related to the historical event. Omega tilde is the thing that we found in the present. That we found in present time. We ignore.
Yeah, what is the P?
Yes, let me get to that. So rho is a vector of properties that this thing had. We have objectual ignorance here. Why? Because we cannot assign the properties that this object had to this. Why? Because it is a distorted object, right? Thank you. Yes, and why do we have objectual ignorance here? Well, because the more important thing here is that we ignore the theoretical reconstruction of the temporal trajectory of the object. Let me explain that with a drawing. Again, what we find in present time is this object, and it has distorted properties. We have a theoretical structure that predicted this, but since we don't know what is the temporal trajectory from this to this, we cannot identify this object with that object. And why do we ignore the temporal trajectory? Well, because we ignore what environmental conditions could have affected this to reach that. What do historians do? They do historical reconstructions. They need to assume these properties, these distorted properties, to reconstruct the properties that the original object had. Let me give you an example. No, before that, let me show you that it was the case with the CMBR. So I said that these are the in any source known to exist at that moment. But also, since they ignored a theoretical structure that I'm going to explain in a moment, look at this. Oh. A ver. Let me go right through that because I don't have much time. So, what did they measure? Penzias and Wilson measured this point. But if Big Bang theory was right, they had to measure this curve. Of course, there is no sense in which from this you can say, oh, well, so the curve is this one. With time, they added more and more points.
We're going to paint on.
No. Well, yes. So if Big Bang theories were right, they had to measure this curve. But they only have few spreaded points along this curve. So they didn't know a priori if the theoretical structure that was the reconstruction of the relic object, that is the CMBR, was a black body spectrum. Why did they ignore that? Because they didn't have enough empirical support, right? So how do you make a historical prediction? I don't think I don't have time for that. Let me just explain this. So we have a theoretical structure from which omega is the empirical consequence. From this, you cannot infer omega tilde. Why? Because you do not have enough theoretical structure. You have to add something here. And this something assumes the object. So it destroys its novelty. Yes. Why? What are some examples? For example, in radioactive processes. So how do we know the life of, how do we know the age of our solar system? We take some meteorite samples and we see what is this reaction that is from rubidium to, I don't know how to say that, the other element. You must search for that. Well, so let me introduce now the argument from ignorance. In order that you have a good prediction, you need two things. You need that the phenomenon predicted is novel, and also you need that the theoretical structure is enough to explain that phenomenon. If you have if you have a phenomenon that is novel, but the theoretical structure is not enough to explain it, then you need to add post hoc adjustments or ad hoc hypothesis or something like that. If was possible that it could not be found. Why? Because the asteroid could have landed in the ocean, and there is no sense in which we can find that crater. There are alternative epistemic criteria to explain Big Bang's adoption and steady-state rejection. For example, empirical amplitude. That is, if a theoretical structure is capable of explaining more empirical data, then it is better. That is what Big Bang theories did, and steady-state theories did not. Also, you can make independent historical reconstructions, and if they converge on the same interpretation, then you have a good argument. Again, Big Bang theories did that, steady-state did not. And finally, coherence. And I think I finished my time. Tres? Okay. So to finish, the new Popperian scheme cannot assign rationality to cosmology's adoption of Big Bang and steady-state rejection. But also, we cannot say that there are many successful predictions in historical sciences. Why? Because the argument from ignorance. When historians find new relict objects, they are not sufficiently explained. When they are sufficiently explained, they destroy the novelty in the object, and we do not meet the two conditions that are needed for successful predictions. Yes, I think that is everything.
Questions? No. This is great. So I love the case study. I love the way you presented it. It's rich, full of riches and things. You did a great job. So, one comment about the new Popperian. Right?
Yes.
So, of course, we all know that that's a false theory. So, how about other attempts, right? So, of course, you offer at the end with the criteria some way of rationalizing it, right? But someone may say, well, okay, you're not picking up some criteria, right? That's justified. We could pick up other criteria that would lead to some other account. So even though now Popperian view is wrong, right? He had a certain conception of the mind. So if you're offering an alternative, it would be interesting to think about, okay, what would be a coherent alternative that actually would justify having all these criteria working together, right? Rather than a patchwork, right?
Yes.
So the thing about Lakatos, right? He was trying to do something like that, right? Offering something a little more flexible than Popper, but he still offers some kind of principle rationalist framework to operate with it. And interesting, some of the criteria you which the program as it evolves, we're dealing with. So I don't think that it's easy to set up what is a research program, that it's easy to bring those things out. But maybe it's, if you're careful about how to reconstruct, maybe you have maybe a smaller core than you thought. And the other elements that you're considering will be just part of the positive heuristics, right? That's how the program is evolving. Right? Look, that's a suggestion.
Yes.
And so, more interesting, you should do your own thing, right? And say, okay, right? And say, look, maybe the ideal research program is, too, vague or unwieldy. But it will be important that if you think about the criteria you select, what will be a conception, right, of science that will rationalize working with those things together. Right?
Okay.
And then try to look how that would work to other historical sciences, right? So, and then that will give you a really interesting picture. But I think, look, it's a great problem.
Thank you.
Yes, I have a question about the dissimilarities between experimental sciences and historical disciplines like cosmology, because it seemed that when you were talking about what makes an experimental science experimental and the type of examples that you gave, that really made me hesitant about buying that distinction. The main idea is if you look at experimental particle physics, for instance, it's very heavily mediated by a lot of technological things that we might not know or we might not understand. And when you look at computer simulations in cosmology, they seem like very much like the same type of epistemic product. So I was wondering what is actually the distinction between those two when you are considering computer simulations in cosmology as a method for inquiry, and when you are considering these type of experiments in particle physics or similar disciplines.
I think that is the bug in the argument. In fact, there is a book that is named Making Prehistory from Derek Turner. And in that book, he says that paradoxically, particle physics, experimental particle physics, resembles very much the work of a historian. When they are, why? Because they reconstruct what happened. There are particles that do not live for long, so they have to reconstruct the existence. In fact, that was the case with the Higgs boson. I do not have a neat argument for that. I think that there needs to be, we need to work on that.
Okay. Well, having read Andrés' dissertation, I also felt that probably he would use lack approach much better than Popper and Quinn, as he already knows. So we will go talking about that.
In the master's dissertation.
About coherency, I also have to say that one of his lecturers is against this like goal of coherent science. And so we can also discuss that. And now I'm going to make my question to Andrés. I was thinking that if I was extreme Popperian, I would say that both Big Bang theory and steady state theory are ad hoc hypotheses. Because they're like in cosmology all the time. They are just fixing, and Popper would be tired of that a long time ago. So both could be like dismissed from this Popperian point of view. And also, listening to you, and thank you for the talk, it's wonderful. I was thinking that probably cosmology is the only part of science that is allowed to see the past, in the sense that data that we received were emitted in the past. And they have this advantage comparing with history.
Yes.
Right? So they actually experiment with past data, and in some sense. And also, just to make some matices, you have some objects that you can actually manipulate, as you were saying with the asteroids And also we have plasma chambers that allows to have objects here that give us all the information about what's happening in the rest of the universe. And not only we construct science with direct observation, also with counterfactual scenarios. So just because you are thinking about cosmology as a historical science, I think this could be interesting to pick up.
Thank you. Just to complement your comment, my argument here is not that historical sciences never behave as experimental sciences, nor that experimental sciences never behave as historical sciences, just that it is rare. My argument is not that historical sciences never make successful predictions, but only rarely the two conditions can be met. So yes, I agree with you.
Thank you, Andrés, for your talk. I think it's a very good study case, and it's very interesting and very difficult. So I have a comment about if you're searching for epistemic criteria to say why we choose scientific, just one theory over the other. I think the criteria that you propose are basically Kuhn's epistemic values, or very similar to Kuhn's epistemic values, or what Douglas recently said about cognitive criteria. So maybe that fits better with a proposal, because epistemic values and cognitive criteria, I think, that are more easy to fit with a structuralism proposal, because they apply easily to a conception of science centered in theories. And maybe that's a better way to put your proposal. But I don't know too much about ignorance, so I don't know how to relate that with structural ignorance, but that's a comment. Thank you.
In fact, if you read my master's thesis, that I took these criteria to be values, because they are easily adapted to the things that happens in science.
Are there any other questions?
Okay, so this is maybe, sí, hablo en inglés o en español?
Yes,
En inglés,
just
oh,
in-
sorry, okay, yeah, took me light. It's not just everybody is covered uniform. Okay, so this is a little wild question. So you're assuming that historical sciences are about the past, right? So that if there are predictions, these predictions would have to be about the past. But couldn't this argument also be seen as a modus tollens? I say, like, yeah, that's because historical sciences have never been about the past. They were always about the present, and they postulated the past to make sense of the present. But of course, if you're looking for predictions, if you think that it is about the past, you would face this kind of problems, or saying, how can you predict the past? So the best way to avoid all these paradoxes, you say, like, no, this has always been about the relics, about the traces, because they are in the present. And if we are going to make a prediction, it has to, if it's going to be a genuine prediction, it still has to be in the present or the future. That's another possibility, right?
Yes, I think that is a much elegant form of presenting the things.
So you see that it's not what you're
because I said that the historical reconstruction is a theoretical reconstruction. Yes, the past is posited so that we can make sense of the present.
Good.
Yes, I think you're completely right.
Okay, then I understood much better.
And you agree now.
I'm sorry, and I agree.
Yes.
Thanks. I also think it's a great project. I also agree with several people in the room. I also have worries, like several people in the room, about using Popper. And I'm still trying to understand why you would need that.
Yes.
If the point is to have some account of rational theory choice, right? That I don't necessarily think that you need to explicitly rely on Popper or Lakatos or Douglas, or you can make your own recipe on the basis of what people have said, and fine, put all those, show that you've done your homework and put all the references in there. But there is a thank you. So that doesn't mean that in this particular case you're looking at you don't have good reasons to say like they pushed it a little too far, or So I was wondering whether you want to make a case in your project about cosmology in general or about this particular case.
In fact, in my master's thesis,
Which will be for sale at the end of
dollars.
the signing event.
So please also have the numbers for the lottery for next week.
I want to explain the first thing that you said, because that is going to connect with the second. So why did I take Popper if it is obviously false?
Yeah.
Because philosophers that are taking the debate in cosmology between Mond and Lambda CDM use Popper.
I see.
Mm-hmm. So those that is my target, to say that they should not be using Popper.
That's important to be said.
Yes.
Yes.
And then you should indicate, for example, you should present this. I know it's in the thesis, but the presentation just briefly indicate, because then your target is not Popper.
Right.
Yes.
Yeah.
Yes.
And that will make it intelligent dialectics.
I was very nervous here, so I forgot to say that. But this is not the Popperian scheme, but the neo-Popperian scheme. That is, philosophers took Popper's insights and reconstructed a very different scheme. For example, this philosopher, this, and a person who's Merit, the famous Merit. And so those were my targets.
Yeah.
What is my project? In fact, what happened is that as I was doing my master's thesis, I found this case, and I realized that the things that the steady state theorists said about Big Bang were the same things that Mond's scientists said about Lambda CDM. And I thought it would be a great prelude to my master's thesis to present this to first say that the neo-Popperian scheme that is proposed to solve the Lambda CDM versus Mond problem does not even solve Big Bang versus steady state. And then proposing my scheme in the Lambda CDM versus Mond debate.
Best luck with the rest of the master's, all the thesis. I do recommend you include Ottavio's dealer's numbers.
Well, yes. I have a question about whether this generalizes to other historical sciences, because of course you're focusing on a very specific case. But I was just thinking about, a long time ago, read, some stuff about the geology, and the amount of traces of different stages of the past is so overwhelming that it's harder to make the case that we don't predict in geology, that there's no accurate predictions. So is it just because of the amount of traces of the past that we may have or not, regardless of the other questions that these kind of problems may happen also in theoretical physics, for instance. But other very intrinsically historical sciences, like a science of continental drift, right? There's an overwhelming amount of traces of different stages of the past. So why wouldn't you just make the regular predictions there? Well, that's kind of sort of works. You might be disappointed because I do not know about geology. But I think that the argument from ignorance can be instantiated in other historical sciences. The case, I do not want to elaborate that here, but I think that the case of the Chicxulub crater is well fit into the ignorance argument. Why? Because when they found a certain thing that resembled a crater, they could not say with any degree of confidence that it was the crater from the asteroid that extinguished the dinosaurs. They needed to make a lot of research to connect the thing that we have, that we find in the present, with the thing that the theory predicted. I think it can be applied to other historical sciences, although I do not know how to respond to the continental drift.
The drift theory was not set as a legitimate theory or a legitimate hypothesis only after that radiochemistry started existing. So it actually depended on a very different type of discipline for us to interpret that as evidence of something else. So I think it actually is not the case for saying that we have a lot of evidence in favor of something in geology.
But why is the fact that it's from a different discipline?
Because they had the evidence before, and Wegener had already proposed the idea, and he had some precedent people suggesting something similar, and still nobody thought that that was evidence. So they had to come with new information, theoretical information, in order to make the reconstruction. And that shows that the evidence in itself was not even recognized as evidence in favor of anything. Because the alternative view, which was a fixist type, they also recovered that evidence and said, like, see, it fits better with the view than with the continental drift theory. So.
Okay. Okay.
Yeah. Is that it?
Thank you.
Oh.